This lesson is going to look at another way of solving a quadratic equation. This time we're going to look at something called the quadratic formula. So just as a review, I'm going to use this equation, y equals x squared plus 9x plus 14. It's graphed using the method we have talked about previously in graphing, and we can see that its roots or its x-intercepts are -2 and -7 as being equal to x. So our solutions to this are x equals -2 and x equals -7. So I want to show to you that the quadratic equation will end up giving you the exact same results. So let's take a look at the quadratic equation, or the quadratic formula tells you. The quadratic formula is -b plus or minus the square root of b squared minus 4ac over 2a. So let's take a look at that same exact equation. I first need to identify my values. So the value of a is 1, the value of b is 9, and the value of c is 14. So I can now go ahead and substitute into my equation. So I have -b, so -9 plus or minus the square root of b squared, so 9 squared minus 4 times a, just 1 times c, which is 14, all over 2 times a, which is 2 times 1. So I can start simplifying this now. I have -9 plus or minus the square root. Underneath the square root sign, I have a lot of stuff going on. I have exponents, subtraction, and multiplication. I would do exponents first. So I have minus 81, because 9 squared is 81, minus 4 times 1 times 14. And I can simplify my denominator as we go. 2 times 1 is 2. So then I would have -9 plus or minus the square root of 81, and then out of what's left underneath my square root sign, I can multiply or subtract. Multiplication comes first in the order of operations, so I would multiply first. So I would multiply 4 times 1, which is 4, and then 4 times 14. So I have 14, and I'm multiplying it by 4. So 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. So I have 81 minus 56. And then that's still over 2. So I have to now subtract what's underneath my square root sign. So I have -9 plus or minus the square root of 81 minus 26, or 56, is 25. And then that's all over 2. So now there's nothing more for me to simplify. So now to be able to find out what I have, I can now simplify only one more piece, which is the square root of 25. So I would have -9 plus or minus 5, because 5 is the square root of 25, over 2. So then I can separate them into two pieces. I can say -9 plus 5 over 2, and -9 minus 5 over 2. So -9 plus 5 is -4 over 2, which simplifies to -2. And then -9 minus -5 is -14 over 2, which simplifies to -7. So I still get the solutions x equals -2 and x equals -7. Let's take a look at one more example. Again, in order to solve a quadratic equation, the first thing, just like with graphing it, you need to have it set equal to 0. So if I set this equal to 0, I have 2x squared minus 3x equals 8. I would have to move the 8 to the other side, so I'd have to subtract 8 from both sides. So I would have 2x squared minus 3x minus 8, and then these two 8s would cancel each other out, and that would be the equal to 0. So now I have my parts to identify. A is 2, B is -3, and C is -8. So I can go ahead and I can substitute those values into my quadratic equation. So I'd have -3 for -b, so that would just be +3, plus or minus the square root of -3 squared minus 4 times 2 times -8, all over 2 times 2. So if I were to start simplifying underneath the square root sign now, I would have 3 plus or minus the square root of negative 3 squared is positive 9 minus 4 times 2 times negative 8. And that would be over 2 times 2 or 4. Move it up. Then I have to still simplify through the multiplication, so it'd be 3 plus or minus the square root of 9 minus, and 4 times 2 is 8, times negative 8 is negative 64. And that would be over 4. I now can subtract underneath my quadratic, or not my quadratic, underneath my square root sign. And I would have to use keep change because I'm subtracting with the negative. So I have 9 minus negative 64. So I'd have to keep the 9, change subtraction to addition, and change the negative to a positive. So I would have 3 plus or minus the square root of 64 plus 9, which is 73 over 4. So this one is a little bit different because I would have to look at it and say, okay, does the square root of 73, is that able to be simplified like the square root of 25 one or was in the previous one that we did? So unfortunately the square root of 73 is not able to be simplified, and it is not able to be reduced either, so we are leaving our final answer as what you see here. So it's x is equal to 3 plus or minus the square root of 73 over 4. So not necessarily all solutions to quadratic equations are nice whole perfect numbers like they were in the previous example that we did.